Thank you very much for that. So I should probably start with an apology, and that's because I'm from Ireland. So if you can't understand what I'm saying, just raise your hand, and as soon as enough hands go up, I'll know to slow down. So my talk is vaguely titled Placebo with Progress. It's because I was sitting on a train to London, and I tried to think of a really fancy title to describe what technical debt was. So this was the result, so I apologise for being vague. That's my name, Caoimhin Graham. The actual pronunciation is below. So if you see me in the pub later on, or if you want to have a chat at the Caoimhin stand, please don't be afraid of saying it wrong. Come and say hello. So placebo is this, I've chosen to name my talk list, so I thought I had to explain what I meant by it. So placebo in medicine is typically used to test new drugs and medication. You have a control set of patients A and a control set of patients B, and you would give control set A a new drug that's untested, and you would give control set B essentially sugar drops, water, something with no medical benefit. Then you can observe whether the drugs are effective or not. So in the context of this talk, I talk about placebo as being proving a falsehood. A placebo is basically telling someone a story and having them believe it. And in the context of software projects, if we tell people that the project's successful, when we actually don't know, it produces what's called the watermelon effect. The watermelon effect is basically it's all green at the outside, but as soon as you drop it, it's all red in the middle. And red, of course, is bad. And I think so I'm from Belfast, I should say, and being from Belfast, there's some historical precedent for a placebo effect, and that my city is famous for building the unsinkable ship that sank in its maiden voyage. This is the Titanic Museum that was opened in 2012, with the shipyards just behind it that the ship was built in. And of course, Titanic's famous for, on its maiden voyage, the unsinkable ship hit an iceberg and sank. And it's not really a great advertisement for Belfast, but what it is a great advertisement for a placebo effect. The ship was sold as being unsinkable. So when the operators of a ship were deciding how many lifeboats they would place on board, they put half as many on for the number of people, the number of passengers that it was capable of taking. This essentially meant that there was huge loss of life on that maiden voyage when the ship sunk, because people bought into this placebo of it's unsinkable. Why would we put enough lifeboats on board? So I've wasted enough time talking about the Titanic. This is roughly the agenda of what I'll talk about. A bit about me, won't spend too long on that. I'll tell you a little about what technical debt is in terms of a definition of it, and I'm going to add my 2 cents to it. I'm then going to describe whether it's bad or not, and the short answer to that now is no, it's not. And I'm going to describe some sort of pointers and guidance about how to identify and manage technical debt going forward. So a bit about me. I should state throughout this talk that these are my opinions and no one else's, so, and I may be wrong, so feel free to tell me at the pub or at the Caoimhin stand that I am. But I've been working for Caoimhin since I left university. I joined as a placement student and worked my way up through the infrastructure side of the business. I'm currently a solution architect, and I've been there for 9 years now. And in those 9 years, I've seen a lot. I've seen a lot go well, and I've seen a lot go wrong. But particularly in the last 3 years, I've worked a lot in central UK government departments to build services to transform how citizens interact with government. And I basically spent 2 years building this, which is register to vote, what is the single biggest change to UK democracy since universal suffrage in 1928. Universal suffrage being everyone is given the vote. And because it's a DevOps conference, this is my first real experience of DevOps. This was 3 years ago, me being put into a multifunctional team with security, testers, ops, developers, everyone that was needed to build the service was in the team. This is eye-opening to me, and I worked a lot for it. So over 12 million people have registered since it went live in June last year. I'm currently working on this government project, which seeks to distribute EU subsidy payments to farmers in England. So if you grow a particular crop in a certain way, you're entitled to, the EU gives you money. And I'm not going to spend too long on this because I didn't realize my colleague Vukas would get a chance to stand up at the beginning. But we run a WebOps Academy in our office in Gdansk, and we have over 200 people working in Gdansk. And Vukas is one of our lead WebOps engineers. If you have any questions about the Academy, please go and find him after this. And that's the only vendor-specific thing I'll say during this talk. Let's actually get on to the meat of this. So what is technical debt? if you go online, you'll find a number of definitions for it. And for me, technical debt is reconciling strategic vision with tactical decision making. That is to say, I know where I want to get to and I know what I need to build, but actually in an agile project, if I'm building it incrementally and iteratively, I'm not going to get the perfect solution first. I need to make tactical decisions and potentially compromise with the solution and getting to that end goal. That isn't to say that you lose vision of what that strategic goal is. You always need to be aware of that. You can never forget that, because if you forget that, you end up accumulating technical debt. And if you accumulate technical debt, it gets very, very hard to repay later on. We'll talk about hard resets later, but hard resets are very, very painful. And I thought at this point I'd lighten things up by talking a bit about Jenga. Hopefully we're all familiar with Jenga. Jenga is I'll say a kid's game, but I enjoy playing it. And essentially the premise is you have a tower and you remove the wooden blocks from the tower and put them on top. The person that removes the block and makes it collapse loses. I want you to think about the height of the tower representing new functionality you're adding to a service. And I want you to think about a scenario where you don't get all of the blocks to start with. You're given 3 blocks every single minute. And I'll challenge you to build a tower as high as you can. You have to start with 3 at the bottom, that's the rule. And every minute then you get 3 blocks. So, and if I'm saying you have to build it as high as you can, you're pretty much going to start in the center and build it up. It'll get to a point, probably after 3 or 4 minutes, if you're lucky, where the tower is very shaky. And the tower is very shaky because the only thing you've invested in that time period is prioritizing functionality over stability. My view is that technical debt demands a maturity and balance of decision making, so that you reinforce the foundation of the service or project as you develop new functionality. Martin Fowler, a preeminent software developer / guru, came up with this technical debt quadrant, where he describes technical debt in terms of 4 key words, those being reckless, prudent, deliberate, and inadvertent. So I'm just going to give you 2 examples of those. There's some on the slides. These are his. And so like reckless and inadvertent. This may be technical debt where you really just want to play with new shiny technology. So you invent an excuse to do it without really considering what it is you're doing. This could be someone putting Docker into production before they even know how containers work and the security impact of it. So it's reckless because someone just decides to use the shiny thing as opposed to doing the research up front. Contrast that with prudent and inadvertent. Prudent and inadvertent might be doing a feasibility study up front to try and figure out which database technology you want to use to underpin your service. And you end up choosing MongoDB. And what you've implemented is a perfect MongoDB cluster. Full replica set, sharded storage, and highly available, and it's great. You've even got it in 2 availability zones. But you get to the end of that project and realize you're using Mongo as a transactional database where you need consistency at the point of write rather than eventual consistency. And actually, it's no longer the most prudent of solution. You need to rip it out and start over again. So technical debt can manifest itself in many different ways. In terms of who's to blame for all this, largely in my day job I am, because I make these tactical decisions about what I want to compromise currently to meet the long-term strategic vision. You're also to blame as well, because I would question whether anyone in the room hasn't contributed or created some technical debt at some point in the past. And we do it for a lot of reasons. We do it because we're ignorant. We don't know everything. So we use, the retrospective prime directive, everyone done, everyone delivered to the best of their ability at the time. No one's going to do a poor job, but we literally may not know enough to do a better job. Money might also be an issue. So, the strategic vision might be the perfect solution, and the perfect solution would be very expensive. So much better to deliver something that sort of gets you on the road to getting there, rather than the end solution up front. Also, you may actually find that you have to rush a solution to exploit a market opportunity. Maybe you've invented the next greatest social network and you want to get it live. Is it more important to get that live and start getting user feedback? when it is to spend a year building it so it's perfect. Get it live, essentially, is the rule there. And I'm sure we've all been in a situation where we've inherited a project that we think will take a month to deliver, and we have 2 weeks. And despite all the weekends and evenings you might contribute to sort of working on that, you know, it may not be possible to deliver it with all bells and whistles. So I thought I'd talk through some examples of technical debt then. This is the classic ops cardinal sin, of course, implementing a single point of failure and knowing it up front. And no one would willingly do this, but it is a compromise that sometimes you have to make. If you have a time-boxed market opportunity, like I was just mentioning, and you need to get something live, do you start with a single database node rather than a resilient database cluster? Well, that gets you to market faster. So that might be a compromise that you have to make at a tactical level, whilst knowing that at some point in the future, you would track that risk and then implement a resilient node. And this is a sort of pet peeve of mine. So to contrast that form of technical debt with this is essentially saying that if I don't implement one-way crypto hashing of passwords in a database, is that technical debt because I can come back and fix it later? And my view on this, and my personal view, is that you never compromise with security. Your customers and your business will not be forgiving of making any sort of compromises around security, so don't even think about doing it. It's not borderline negligence, it is. So if you have a security story, do it properly up front and get the final solution in place, rather than sort of wasting time with a patch. Technical debt seems to get a bad reputation for bad code as well. Call bad code what it is, it's bad code. Lots of technical debt is implemented using really elegant code. So let's distinguish between both. So that's sort of what technical debt is. What I'll talk about now is whether I believe it's bad or not. Everyone seems to conjure an image of someone up to evil whenever they sort of hear about technical debt and, oh, someone's creating it, is it bad? In my view, it isn't bad, because it's empowering the organization to, at a tactical level, adjust and pivot to market demands. What is bad about technical debt is not being aware of it or failing to track it. Ignorance is great because you don't know any better, and it's very easy to ignore, but it will come back and bite you, and I'll talk about that later. So I've got another terrible analogy, and I'll throw it out there. So I was trying to think of something that would sort of be a parallel to technical debt, and it would be, so ignoring it is like building a house on a cliff's edge without ever inspecting the cliff or the threat it poses to your house. And to use the Jenga analogy, you just keep adding more bricks to the top. And because you can Google for this sort of stuff, you find images for it. And I found a really appropriate one, which is this. This is essentially what happens if you ignore technical debt. Your house will end up in fire at the bottom of the cliff, and you'll need the fire brigade in to help fix it all. And technical debt can be slow to build. It doesn't happen overnight. It takes time. And because it takes time, it becomes very easy to ignore. And eventually it will reach a critical mass where it can spiral out of control and form a vicious cycle. What I mean by a vicious cycle is that, so you have service in production. Customers start complaining about the performance of the service. Releases for the service are beginning to take weekends. The number of defects that are reported for the service are ever increasing. And the business put you under pressure to fix it. The business put you under pressure, so you have to take shortcuts to address the technical debt. So you replace the technical debt with more technical debt, and so the cycle repeats. And so over time, you eventually spiral out of control. This is and I can't say this word, an Ouroboros symbol, which is a snake eating its own tail. And basically that's it. Technical debt can feed itself under the right conditions, and you should be aware of that. So the moral of this talk really is that if you establish good habits around managing technical debt, they can enable your organization to pivot and meet market opportunities. If you establish bad habits, then they can almost disable your organization once it gets to a point. I'm going to briefly talk about this. I'm sure people in the room have heard of this theory before, but this is broken window theory, and it was coined in the early 80s and relates to criminology. And broken window theory states that If you let small crimes go unpunished in society, you actually encourage greater crimes to occur. That is to say, for this building, it may have started life as pristine, no broken windows in sight. Someone came along with a stone, threw it, broke a window. If you don't replace that broken window and hold that person to account for that crime, you're essentially encouraging more to do the same. So if you leave that broken pane, you might have a second broken pane, then 5, then 10, and eventually it might spiral out of control to this and lead as a gateway to more serious crime, like people breaking in, stealing materials, like people squatting, or potentially burning the building down. It can get very serious. This is not me drawing comparison to crimes in software development. This is more me saying that if you let bad habits occur, they will continue to occur. If you reinforce good habits, they'll stick, and you'll benefit from that. And in the last section of this talk, I just want to really mention ways that I've used in the past to identify and manage technical debt going forward. You need to know how much you have to start with. So there's no point, if you're starting from scratch, you need a way of identifying it, a way of qualifying it, and a way of prioritizing it, because otherwise it's a very uphill struggle. So to identify technical debt, this can be a difficult thing. My advice would, so there's a phrase in industry, and it's monitor all the things. That's very important, but actually there's some key metrics you want to monitor that will give you telltale signs as to whether you have this surging amount of technical debt. One is your team's velocity. If you notice sprint on sprint that your team are delivering less and less and less, but chances are it's because they're having to work around technical debt. If you address it, you'll see your team's velocity increase again. If your releases take weekends or weeks or months, something's going wrong or something that needs to be fixed. So if you have a nightmare release, chances are you have technical debt. If you have a really closely coupled application, so like a huge monolith sitting in the middle of your estate, chances are that's technical debt as well. Twitter had this problem. We already mentioned, I think Luca mentioned about switching to a service-oriented architecture for another customer. Twitter had the same thing. They had a huge monolithic Ruby on Rails application that required, well, if you joined one of our development teams, it would take you weeks, if not months, to get up to speed about how it all knitted together and worked. It was technical debt in itself. So Twitter, of course, they split it out. They went full service-oriented architecture. And now, as we all know, we're hugely scalable. It's not to say that every service needs to be hugely scalable, but Twitter identified that technical debt. That would have been quite difficult to repay, in that it would have been a full refactor almost of all their code, but they paid it, and now they're reaping the benefits of it. So that's how you identify it. You basically have a look at what's going on in your teams and your development process, and you basically monitor it over time. I say monitor it over time because trends are more important than specific data points. So if my team's velocity drops below 25 story points, well, that's not telling me I have technical debt. But over the course of 3 months, if I see what the graph is going down like that, I know there's something going on. Next, you have to qualify it. My advice is start with something really simple. Start with something that works for you. Could be a post-it note with those 3 things on it. The 3 things being a description of where you found the debt. So in a project I've worked on, we just have a Slack channel where we will ping in a 1-line description of where we have found the debt and what we think we need to do to fix it. An effort estimate. Use whatever metric you want. It can be days, it can be story points. I don't know, it can be like revolutions of the sun around the solar system or whatever. But put something against it so you know how painful it will be to repay. And then impact assess it. When I say impact assess it, think of it in terms of people. How often will people look at that particular function, which is awful, that requires them to spend an hour figuring out how it does what it does? Think about it in terms of, if I was making future changes to that code base, will I need to extend that particular function? So if the code will be used again in future and will need to be maintained, chances are it's going to have a higher impact than code that's used once a year. And then prioritize it. Once you've qualified all of your debt, it'll be really easy to figure out which areas you need to focus in. And if you do need a rough rule of thumb, so good debt is new debt, in my view, technical debt is tactical decision making at its best. So debt that is 1 or 2 months old is fine. Debt that is years old, potentially decades old, needs to be fixed. So that's a guide to how you prioritize. And you'll get to a point where you need to pay it back. How do you actually do that? The most simple answer I can give is factor it into your cost of development. So if your team has a velocity of 30 story points a sprint, take 5 of those and just pull in stories relating to technical debt. Do it as an ongoing thing. Build those good habits into your teams so that in addition to adding the new functionality, you're also shoring up and stabilizing the platform. And there's 3 terms you can use to describe how you repay technical debt. One is debt repayment. That is to refactor everything, what Twitter done. Rip it all out and start over again. Refactor that. Debt conversion. That is to replace technical debt with another minimum viable product. That's another MVP. So it's something that isn't perfect, but something that's better than what you had. And the last option is if you're happy maintaining with that and it's really causing no one problems and you only use the code once a year, well, as long as you're aware of the maintenance cost associated with it, just service the interest. And that's the end of my talk. Thank you very much for listening. I'll take any questions if people have them. Hello, be gentle.
Thank you so much. Seems like dealing with technical debt is like an ongoing process. Do you have any questions that came in? Not yet. Okay, maybe so.
I must have explained it all so well.
Bro, there are no doubts. Okay, thank you so much, Caoimhin.